Hi, in this problem we want to find the first partial derivatives of a function here of three variables. F of x, y, z is z arctangent of y over x. And so we'd go through this, or f sub x at x, y, z here is going to be partial with respect to x of the z arctangent of y over x. Well, the z can come out because relative to partial with respect to x, it looks like a constant. Right? And then here I have my arc tangent y over x. So here I have the arctangent of a function, so I need to use the chain rule. This will be a z, it's 1 over 1 plus y over x squared times the partial with respect to x of y over x. Okay. Well, so this is going to be a z times 1 over 1 plus y squared over x squared. And this looks like y times x to the minus 1. So we're going to have a y times negative 1 x to the minus 2. And then I can do a little bit of simplification here and write this as negative yz over x squared plus y squared, right? Because I have the z times 1 times y times negative 1 in the numerator. X minus 2 is 1 over x squared times this fraction here just gives me x squared plus y squared. So that's a partial with respect to x. The partial respect to y of x, y, z. So the partial respect to y of z and then arc tangent y over x. And relative to this operation here, the z looks like a constant. So I have a z times partial respect to y of arctangent y over x. And now again we use the chain rule. So this will be a z times 1 over 1 plus y over x squared times partial respect to y of y over x. Well, this is going to be a z times 1 over 1 plus y squared over x squared times 1 over x. And then I can simplify this if I want to. And then finally, the partial with respect to z here, partial respect to z of z arctangent of y over x. Well, y over x look like fixed numbers, so the arctangent y over x is fixed. If I had z times a constant, I just get that constant when I differentiate, and here I'm just going to get that. I'm just going to have arctangent of y over x.